The goals of the Carruthers Geocorona Observatory are to study the nature and origin of Earth's exosphere and how it evolves over time.
The exosphere itself is the uppermost layer of the Earth's atmosphere. It's comprised almost entirely of atomic hydrogen. This is the lightest chemical species in existence, and it floats away, essentially evaporates off of the top of the atmosphere. And when the sun shines on these atoms, they essentially scatter it off into all directions, and so it glows like a gigantic halo around the Earth. And so that's called the geocorona, that fuzzy halo of light that's given off by those exospheric atoms.
Many times we think of the transition between the atmosphere and space as being this very abrupt boundary where at one altitude you've got atmosphere and the next altitude you have space. But in reality, this transition is much more gradual and can extend over thousands of kilometers. By imaging the geocorona, we can actually answer fundamental questions about the size of the exosphere, the structure of the exosphere, and how it changes over time. And all of this in response to the input from the sun. The Carruthers mission has a near-field imager and a far-field imager. The near-field imager lets you zoom up really close and see how the exosphere is varying very, very close to the planet. The far-field imager is actually going to let you see the full scope and expanse of the exosphere and how it's changing far away from the Earth's surface.
Understanding how that works at Earth will greatly inform our understanding of exoplanets, for example, and then how quickly the atmospheres can escape.
Now, the first image of the exosphere that we ever got was obtained by an instrument made by Dr. George Carruthers, who was a very outstanding scientist and engineer who created a telescope that landed on the moon in 1972 as part of the Apollo 16 mission.
Houston, the Earth is maybe a quart. It's right in the middle. Outstanding. You did a good down center alignment.
That telescope gave us our first picture of the exosphere, but it couldn't see the entire exosphere.
He wasn't far enough away, being at the moon, to get the entire field of view. And that was really shocking, that Earth's exosphere can be that big, that this light, fluffy cloud of hydrogen around the Earth extends that far from the surface.
The Carruthers mission fills an important gap in NASA's heliophysics fleet. We've never had a mission before that was dedicated to making exospheric observations and continuously observing the exosphere, being able to see its full scope and shape. And it's really exciting that we're gonna get these measurements for the first time. And I think that's really groundbreaking for this mission.